Motion is all around us, whether it's the bus that moves on road and takes you to your school, or you riding your bicycle. Let's dive in and learn more about motion. A body is said to be at rest when its position does not change with respect to a reference point. On the other hand, a body is in motion when its position changes continuously with reference to a point. Now, motion can be of different types depending on the path the object is taking. Circular motion means the object is moving in a circular path. Linear motion means the object is moving in a straight line path. Oscillatory or vibratory motion means the object is moving to and fro with respect to its origin. Now, let's understand the difference between distance and displacement. Distance is the total length of the actual path traveled by an object. It is a scalar quantity, which means it has only magnitude. Distance is always positive and cannot be zero or negative. Displacement, on the other hand, is the shortest length between the initial and final points of an object's motion. It is a vector quantity, meaning it has both magnitude and direction. Displacement can be positive, negative, or zero. Now, motion can be of two types, uniform and non-uniform motion. Uniform motion is when a body travels equal distances in equal intervals of time. You can understand this motion better by this graph. See how equal amount of distance is covered in equal amount of time intervals. Non-uniform motion is when a body travels unequal distances in equal intervals of time. You can understand this motion better by this graph. See how in time interval 1, the distance covered is less than the distance covered during time interval 2. Now, how do we tell how fast or slower motion is? Yes, we tell this by using speed. Speed is the measurement of the distance traveled by a body per unit of time. So, speed is equal to distance upon time. The SI unit of speed is meters per second, ms. If a body is in uniform motion, then its speed will be constant or uniform throughout the motion. However, if a body is traveling with non-uniform motion, its speed will not remain uniform but will have different values throughout the motion. For non-uniform motion, we use average speed, which is the total distance divided by the total time. Now, you might have heard about another term that is very similar to speed, velocity. Velocity is the speed of a body in a given direction. It is calculated as the displacement divided by time. For non-uniform motion in a given line, average velocity is calculated in the same way as average speed. For uniformly changing velocity, the average velocity can be calculated as the sum of the initial velocity and final velocity divided by 2. That is, average velocity is equal to u plus v upon 2. Here u is the initial velocity and v is the final velocity. Now, we know, in non-uniform motion the body is changing velocity. So, non-uniform motion can be of two types, accelerated or decelerated. Acceleration is defined as the rate of change of velocity with time. It is calculated as the change in velocity divided by time. Acceleration is equal to v minus u upon t. Deceleration is seen in non-uniform motion during a decrease in velocity with time. It has the same definition as acceleration, but in this case, the final velocity is less than the initial velocity, resulting in a negative acceleration value. So the formula is the same. But the v is less than u. Now here, we have graphical representations of position-time graphs for different types of motion. The first one is distance-time graph for a uniform motion. See how a body covers equal distances s1 and s2 in equal time intervals. The second one is distance-time graph for a non-uniform motion. See how a body covers unequal distances in equal time intervals. The third one is distance-time graph for a body at rest. See how the distance remains the same as the time increases because the body is not moving. Now, these are graphical representations of velocity-time graphs for different types of motion. The first one is velocity-time graph for a uniform motion. See how a body is not changing its velocity when the time is increasing. This is because in uniform motion the velocity of the body remains the same. The second one is velocity-time graph for a uniformly accelerated motion. See how the velocity changes by equal amounts in equal intervals of time. The third one is velocity-time graph for a non-uniformly accelerated motion. See how the velocity changes by unequal amounts in equal intervals of time. Now, when it comes to motion, there are three main equations that we use to solve a problem. The first equation is v is equal to u plus at. The second equation is s is equal to ut plus half at square. The third equation is v square is equal to u square plus 2as. In all these equations, u is equal to initial velocity, v is equal to final velocity, a is equal to acceleration, s is equal to displacement. Now, uniform circular motion is when a body moves in a circular path with uniform speed. Although the speed remains the same throughout the motion,